Hello everyone. In this video I'm going to talk about the buoyancy force, and buoyancy force is a type of force for objects that are immersed inside the liquids. For example, it's very easy to understand this buoyancy force when we have a prism shaped object inside the liquid. And remember, we just talked about the hydrostatic pressure. So look at this prism, right? So it has basically a cross-sectional area here, and then has another cross-sectional area at the bottom, right? So if you consider this, then you see that there is a pressure, hydrostatic pressure, acting at this depth, right? So this hydrostatic pressure is acted by, the pressure here, right, is the density multiplied by at this area, right? Applying to this area is equal to pressure multiplied by A. That's the force being applied, right? And the pressure is the hydrostatic pressure. So 0.052 density multiplied by this depth, right? And then there is another surface area at the bottom, and there is a force applying to that surface, the pressure applying perpendicular to the surface, right? So this is where the force will be upward, therefore, right? So F2 is equal to P2A, and P2 is equal to 0.052 density multiplied by D plus H, where H is the length of this system, right? So the final, or the resultant force, is F2 minus F1, right? And that is going to be, if you do the calculations regarding that, you get basically an equation for the buoyancy force. Now, based on the buoyancy force, an effective weight is defined. So the object feels less weight. When you want to take out an object out of the liquid, you feel that you need less force basically to be applied to that, right? So that weight is called the effective weight, which is equal to the weight of that object multiplied by minus the buoyancy force. And buoyancy is then defined as the weight of the displaced fluid. So if you did the calculation here, the difference between these two forces would be the weight of the displaced fluid. And how do you calculate the weight of displaced fluid? So you need to have the volume of displaced fluid, which is equal to the volume of the object, right? Displaced fluid, and the weight, or the mass actually, right, is equal to density multiplied by volume. So this is density of fluid. So density of fluid multiplied by the volume of the object or displaced fluid, which are equal to each other, this is called buoyancy force. Makes sense? So buoyancy force then is density of fluid multiplied by the volume of the object, and W minus that would be the effective weight. Now in our case, we have basically casings or drill pipes, which we will talk about that later. But here in this case, we have the effective weight. You see definition here. W is weight in the air. It means that it's not in the liquid, the actual weight of that object. Fb is the buoyancy force. V is the volume of the body or volume of the displaced fluid. Rho F is the fluid density, and rho S is the body density. Now this volume, as I said, is the volume of the body or volume of displaced fluid. So volume of the body, or the object that you are talking about, it is equal to the weight of that object in the air, right, divided by the density of that object. So if you do that, then you can factor out W and get this equation for the effective weight, which is the weight in air, right, multiplied by 1 minus the density of fluid divided by the density of the object. So this 1 minus rho F over rho S is called the buoyancy factor. And that's a factor that you multiply by the weight. So it's basically a number between 0 and 1, and it's not going to be 1. It's definitely less than 1 and more than 0. So it's a fraction of the weight of the air. The effective weight is a fraction of the weight of the air. So as an example here, the density of the steel is 65.5 pound per gallon, and it is immersed in a mud drilling fluid, which have a density of 15 pounds per gallon, and the buoyancy factor for this specific case is 1 minus 15 over 65, which is 0.771. So if you have a drill string which is 100,000 pounds in the air, then the weight that you feel when you want to take it out of the drilling fluid, do a trip or connection or whatever you want to do, it feels to be 77,100 pounds instead of 100,000 pounds. Alright, so next we're going to talk about the aerial forces in drill string in the next video.